Dr. Babasaheb Ambedkar Open University.
Welcome back again. This is Disha Parekh. We had been seeing, of course, the Block 1 Unit 2, alright, and today we will be seeing the further topics of Unit 2. Last session we saw was work breakdown structure, alright, which we commonly called as WBS, right. Secondly, we saw was software sizing, alright, where I mentioned something called as FP and LOC, alright, and then we saw was milestones baseline. Today we will be seeing is cost estimation techniques, alright, that again includes my software pricing and my software cost, alright. Then we will be seeing is software, of course, pricing, that means FP approach and LOC approach. Then we will be seeing what is Kokomo model, and before that we will be seeing how to construct an activity network diagram, alright. So let us start with today's session. First topic is cost estimation, okay. What is its aim? It aims at predicting the software development cost. Now, if you would read the term cost estimation, it itself states that it is going to estimate the cost for my software development, right? It is going to estimate or predict the cost for my software development, alright. So, that is cost estimation. There are actually two different terms associated with cost estimation. First being software development cost, kindly focus on the word cost right now, and second being software pricing, right, kindly focus on the word pricing right now. Now, if you see cost and pricing, they both in software engineering is different terms, right. I will state how. Project cost is that computed as a bidding price to a customer. When you bid some price to your customer for your software development, alright, then we call it as a cost. But when you include profit into that cost, whatsoever cost is incurred in your software development, when you add profit into it, it becomes a price of your software, alright. So, there is two different terms, software development cost, that means cost related only to your software development, wherein you have not included your profit, and once you include your profit, it becomes software pricing, we call it as a price, right. Now, there are three approaches to estimation. The first being empirical estimation. This is always based on the past experience. For example, if I am to construct some software which was a similar kind of software that I already have built up in the past, alright, then in that case I know the cost estimation, rough estimation of the cost. So, on the basis of my particular previous project, I estimate the cost for it, we call it as empirical estimation. Next is heuristic estimation. This is based on mathematical expression, alright. We have certain formulas to calculate this, and on the basis of that formula we come out with some cost, and we call it as heuristic estimation. And last is analytical estimation, which is based on assumptions. I am not going to deal with what my past project was, not going to deal with the formulas or any mathematical calculation, but I will simply assume that yes, this is what I am supposed to build up, then in that case my particular software development cost would be so and so, and that we call it as analytical estimation. Now, before we move to FP and LOC approach, we need to understand what is Rayleigh curve, alright. Rayleigh curve is a distribution model which shows development of programs effort which ramp up the peak value and over certain time frame. If you see this diagram, alright, if you see this diagram, this is what you call it as a Rayleigh curve. It says that it is reaching to a peak point. At what time? At time 20, alright. So, when it reaches to a 20, the peak point at 20 a time, we call it as Rayleigh distribution model. Alright, so it shows development of programs effort. So, my programs effort is highest over here at this point, which ramp up the peak value and over certain time frame, after which again it goes down. Alright. When you want to calculate this Rayleigh development, there is a formula which is RT is equal to C 1 minus E raised to minus 0.5 T by D square, alright, where your T, RT stands for total cost or effort expended to time T. For that particular time T, whatever total cost or effort you have incurred comes under RT. C is your cost scale parameter, that is final development cost of your product. D is called as schedule scale parameter. For example, whatsoever duration you take up, D stands for duration, whatsoever duration you take up to build up your entire project comes under D. Alright. So, if you put this particular all the parameters in this equation, you will get a curve which is called as a Rayleigh curve. Alright. Now, one of the most important topic of this particular unit is LOC and FP estimation. Now, what is LOC estimation and what is FP estimation? They both are entirely different. Before we move to what it is, what are its advantages, what are its disadvantages, let me quickly brush up that in the previous session we saw what is software pricing. There I said that if I calculate the number of lines that I put into my software is called as line of codes, which we call commonly as LOC, right? And FP is something that counts my functionalities within my software, alright. So, for example, if my software has 11 functionalities in it, then those 11 functionalities is counted as my FP metrics, alright. So, let us now move further deep into that. LOC is line of code used as a predictor of program features like effort and for ease of maintenance. Alright, it is very it includes features like effort and it is very easy for maintenance, alright, and it is predicting my program's features. Alright. DSI, which is delivered source instructions, DSI stands for delivered source instructions, used in Kokomo 81, which we will see at the last what is Kokomo model, as KDSI is explained as source lines, right. We call line of code as source code. If you remember, we call generally as source code of our program. So, source lines which deliver portion of product like test drivers and support softwares that are obtained by project staff by creating application generators, then we call it as line of code. So, my line of code is not only what I code, alright, it even includes all the test drivers, all the support softwares that I have used, alright, all those supporting software, their line of codes, their particular thing, whatsoever is there, their source of code, alright, everything is included in LOC. It has single instructions in one line of code or a card image. It will have only one line of instruction, right. In this, the instructions are declared with no comments. So, we are not supposed to have any comments in our line of code. Mind it, line of code means originally what you have coded, not the comments. Now, what are its pros and what are its cons? Pros and cons means disadvantages and advantages of LOC. Advantage of LOC is just one, it is simple to measure. It is very simple to measure. You say somebody that I have coded a project, acha, how much line of code is it? And you say 32,000 lines of code, that is it. That is your estimation of the project, that your project is going to be very huge, alright. So, it is very simple to measure, but it has lot many drawbacks. First being, as defined on code, it is hard to measure size of specification within it. It says that when you say 32,000 lines of code, those lines of code would not be satisfying maybe some customer requirements, right. So, whatever specifications were there, probably it is not fulfilling those specifications, though the lines of code is too huge, right, but the specification is very minor kind of thing, or probably that particular specification or that particular requirement is not being fulfilled on those 32,000 lines of code, alright. So, that is one of the drawback. Second is, It is limited to particular size, namely length, and has no functionality or complexity. As said, it is not going to be specific to the customer's requirement also, alright. It might fulfill customer requirements, it might not fulfill customer requirements. So similarly, it might not include all the functionalities or maybe not all the complexities of your software, right. It has great line of code due to vast software design. Sometimes people, if they say I have 32,000 lines of code, you will think that yes, that means his or her software designing was not proper, because it says that it is not essential to have more lines of code, but it is very much essential to fulfill what you want. The output, if you are getting with 15 lines of code and the same output with the same functionalities, with the same features is given by just 5 lines of code, then coding those 5 lines of code is more important, right. Then it depends on certain language, it depends on the language. For example, certain languages would code certain functionality in just 2 lines, right. For example, Python uses very few lines of code, and if the same program with the same functionality, if you code into some C language or something, it would be a huge code, right. Hard for users to understand. It is very hard for users to understand if it is very huge line of code. If somebody gives you a package of maybe 1 lakh lines of code, understanding that lines of code is very, very difficult, right. Next, let us see what is FP estimation, or we call it as function point metrics. FP, which is function point, is basic data from which the productivity metrics could be solved. So this is one which gives you productivity metrics. Productivity metrics means how productive is my software, whether my software is giving all the functionalities, whether it is productive with 100%, 90%, 80%, what is the productivity ratio of my particular software is always calculated based on the function point. Such type of data is used in 2 ways. What are its ways? First, it is used as an estimation variable used to size every element of a software, and secondly, it is used as a baseline metrics. Previously in this session we saw what was baseline, right? Baseline, milestone, baseline, right? So it is even going to form my baseline metrics, that how my software should work, alright, and what are its productive features, what are its characteristics that I am going to provide within my software comes under baseline metrics. Now it counts functions like, now I said that it counts external components. Now what are those external components? They are external inputs that you take, they are your external outputs also, they are your queries that you fire for your particular software, they even include the external files that were there, and they even include your internal files, alright. So external internal outputs, external internal files, and your queries that you fire, right, all this comes under FP estimation. Let us look at the advantages and disadvantages of FP estimation. Advantages being not specific to code, it is not going to be specific to code, alright, it is going to be specific to the functionalities that my code is going to provide. Has no dependency on the language, be it XYZ kind of language, alright, it is not going to be dependent on the language, it is only going to focus on what kind of functionalities my product is going to serve, alright. Data is seen early in project as detailed specification. A data is particularly seen as a detailed specification. It is going to be very, very accurate, highly accurate, more accurate than my LOC approach, right. And its drawbacks of FP estimation are very difficult to automate and hard to calculate, right. Let us first change this. Drawbacks of FP are, it is very difficult to automate and very hard to calculate, because I am not supposed to only have lines of code which is very simple to calculate. No, I am going to actually calculate all the functionalities that my product is going to provide me with, be it internal to my project, be it external to my project. So counting all those functionalities is very hard, very difficult to calculate. Then it does not consider quality of output, it does not consider the quality of output, it only considers that functionality 1, 2, 3, yes it is satisfied, yes done. Then more towards traditional data processing applications, it is going to be more towards our traditional data applications, right. And Effort prediction by unadjusted function is worse with addition of TCF. TCF stands for total cost of functionalities, right. So, effort prediction by unadjusted function is worse with our TCF. And lastly, requires subjective counting. Because it is following traditional data processing applications, it requires a very subjective counting of all the functionalities. You do not have to miss any single functionality, because it is on the basis of functionality that your metrics will be counted, your particular cost of your software is counted, right. Next, now as said, FP and LOC is the most important part of your unit 2, right. Similarly, if you develop some software but you do not document it, all right, then that software has a very less value. Now, what is documenting a particular software or a schedule? A written text that accompanies computer software. Now, when you give a particular software to a person, you need to give the manual also. For example, if you purchase some phone, you purchase a new brand phone, you get a manual with it, right. Without that manual, you will not ever have any other things, because if you are a first user to that phone, you probably don't know what all features are there in the phone. So, you read that manual, all right, and from that manual you come to know that yes, this particular thing if I press, I will have this many features. So, similarly, when you document your software, a person who is going to read that document will come to know that what your software is, how much valuable your software is going to be, right. So, it is a written text. It explains operation and usage of software. Just like your operation of your mobile phone is being explained in the manual, similarly operation of your software and usage of your software is explained in your documents. Types are requirements, you have to document the requirements. Architecture or design, you have to even show how an architecture or how a design of a software is there, how your software ultimately looks like, all right, all the technical description that is required to run your project. End user, all right, who can use this software, how much effective this software is going to be for n number of users, all right. Marketing, what all marketing strategies are there for this software, why is this software so much important in the market, right. All this comes under documenting, all right. Now, project scheduling includes splitting a particular project into different tasks, all right. You have to particularly divide your particular project or a software into task 1, task 2, task 3. I will show you a diagram after this. Organizing tasks concurrently to utilize workflows optimally. I do not have to use, if I am working with task 1, my task 2 cannot happen, no. If I am working with task 1, my task 2 also should happen. For example, if you are listening music in your phone, does not mean you cannot chat, right. You can chat, you can use your WhatsApp also, you can listen your song also, so it is simultaneous task being operated. Right. Minimizing task dependencies to avoid delays, you have to minimize the task dependencies to avoid delays, right. And dependent on project manager's experience and intuition, it is always on the project manager's experience that a particular this is done, all right. Let us see how a process is done. Please pay attention. We have to first identify the activities. Whatever activities are there, just identify all those activities, all right. After identifying an activity, identify its dependencies, that activity 1 is dependent on activity maybe 0, or activity 2 is dependent maybe on activity 1, all right. So, identify the activities, identify its dependencies. Once done, estimate all the resources, how many resources would I require. Now, in order to fulfill maybe activity 1, I require some XYZ resource. In order to fulfill maybe activity 2, I require some ABC resources. So, estimate all the resources. After that, people allocation is done, that this particular person will do activity 1, this set of people will do activity 2, this set of people will do activity 3. So, people allocation is done. Then, create project charts, all right. You have to create project charts that yes, this particular set of people is doing this much task, all right. Then maybe set of people 2 is doing this much work, and even you can estimate your resources, you can create your project charts, all right, on the basis of your resources, all right. So, this is how you construct a particular project scheduling process. identifying the activities, then discussing its dependencies, then estimating the resources, allocating all these activities to different set of people and creating a project charts for them. Now, scheduling is analyzed on basis of, how do you analyze a schedule? It is analyzed on basis of the end date for release of computer based system. Mind well, we are going to see what are end dates, alright, and end date set by software engineering organization. I am skipping for time being the second point, just read end date for release of computer based system and end date set by software engineering organization. So, if I am asked that when I am going to deliver you a software, probably I would say after 2 months. But when originally it comes, I am able to deliver you software maybe only after 65 days. So, those 5 days more that I took is something end date for release of computer based system and end date set by software engineering organization. So, stated was 60 days, that is 2 months, sorry, stated was 2 months, right, and actually when I gave it was 65 days, alright. Then second one is releasing of effort by software organization in a particular time frame. Sometimes it is very much essential to deliver a particular software maybe before time or on time, not at least after time, right. So, releasing of effort by software organization in a particular time frame is always done with the help of scheduling, alright. Let us see the next topic. It is activity network diagram, which is again very easy. Okay. What is activity network diagram? It is a graphical way to analyze task dependencies that we saw in 2.8 and the critical path in the project. Alright. Let us develop one activity network diagram, which is again very easy. If you see, I start here with my process. Alright. Start identifying the activities that we saw in 2.8. Right. Start. When start, I have two tasks given to me, task 1 and task 2. Now, from task 1 and task 2, I evolve out one another task which is called as task 3. So, from task 1 and task 2, I evolve out another task which is called task 3. So, this states that my task 3 can commence only after I complete my task 1 and task 2. Again, I am repeating, I have started with two tasks simultaneously, task 1 and task 2. Now, once those two tasks are completed, after that only I can start with my task 3. But there is another task which is task 4, which actually starts after the completion of task 2. So, if my task 1 is remaining, doesn't mean that I cannot start with my task 4. Because my task 2 is completed, I can start with my task 4. But only if I complete task 1 and task 2 together, alright, then I can commence with my task 3. I hope you can see the arrows. Then task 3 and task 4, when they are completed, right, both of its outputs, the result gives a product called as task 5, alright, and task 5 is where I end my process, alright. So, task 1, task 2. Task 1 and 2 after its completion initiates task 3, task 2 after its single completion initiates task 4, task 3 and task 4 once completed, its output is merged into some other task, we call it as task 5, and there we end with the process. Now, pay attention, these arrows that we see, right, are called as dependencies. So, this arrows, all the arrows are called as dependencies. This are our task, alright. So, it is a way to analyze your task, your dependencies and the critical path in a project. Now, let us see two major definitions. One is predecessor and one is successor. What is a predecessor and what is a successor? Now, if you consider task 4, task 4 is a predecessor of task 5. That means task 5 cannot work before my task 4, right. So, task 4 is a predecessor of task 5, while task 4 is a successor of task 2. That means only after I complete my task 2, I can successively go to my task 4. Alright. So, this is a predecessor to task 5 and this is a successor to task 2. Alright. So, predecessor, successor, dependencies and task. Alright. I hope this would be clear with the activity network diagram. You can have n number of activity network diagrams depending on the number of tasks that you have and depending on what task is dependent on what other task. It is very much mandatory that you reduce the dependencies. Alright. It is a good coding practice if you can reduce the dependencies of individual task. Right. Let us now see 2.10, which is empirical relationships. Right. It translates all the relations of formal relational systems. Alright, and there are 3 relations that exist. First is inequalities. Alright, inequalities means if there is something very much not different, if there is something which is different from one project to another project or maybe one module to another module, we call it as inequalities. Then we have is equalities. If my particular 2 modules are there, both the modules have equivalence function, alright, both of them have equal function, we call it as equalities. And special value assignment, for example, certain functions that we keep are abstract class, abstract functions, right, all those which returns you 0 and probably after that it is used somewhere in the project, then we call it as special value assignment. Alright. 2.11 is effort distribution, an exercise to produce cost estimation report normally required to get the percentage of every phase. I hope you can see this diagram. There are 4 phases there: analysis, design, implementation, test. Now, analysis of 20%, design is 40%, implementation is 15% and test is 25%. So, I have distributed my work accordingly. Now, if you see my designing part is of higher percentage, then effort required in designing is going to be more, right. Percentage of effort distribution was obtained using empirical data, okay, and phases included are requirements gathering, you can gather your requirements, analysis, right, then development, which we generally term as implementation, and testing, right. So, these are the 4 phases which is included generally to distribute my effort, alright. 2.12 is empirical estimation technique, which we call it as Kokomo model, right. Now, what is Kokomo model? Before that, we see what is empirical estimation technique. Software cost estimation predicts the amount of effort needed to create a software system. So, if I am going to create some software system, what or how much effort I require to create this system is called as software cost estimation. Starts with software life cycle and continues throughout the lifetime. Boehm is the one who has classified this estimation cost into expert judgment, algorithmic estimation and analogy based estimation. For your time being, for in your syllabus you just have algorithmic estimation and we will see to that estimation. Kokomo is constructive cost model. I hope you can see COCOMO, that is Kokomo, constructive cost model, which is algorithmic method depending on the mathematical model. Alright, and it is of course given by Barry Boehm in 1981 and there is going to be code size as for some 1000 lines of code, which we call it as KLOC. K stands for 1000, right, KLOC, resulting in person month. If you see the Kokomo model are of basically 3 types, but for your syllabus it is of 2 types. Simple Kokomo, which is having a formula, a very small formula, effort is equal to A into K log raised to B, where A and B are your effort distribution, alright. And there is an intermediate Kokomo model, which is also called as nominal effort estimation model, alright. So, there are basically two types of Kokomo model. One is simple Kokomo model, which has this formula, and another one is an intermediate Kokomo model, which you call it as nominal effort estimation model, alright. That is it with the unit 2. The learning outcomes of unit 2 are work breakdown structure. We saw what is WBS. We saw what is software costing, right, that is software pricing. We saw what is software documentation, how do we document a software, right. We saw what is activity network diagram, how to draw that activity network diagram, right? We saw what is Kokomo model, right? That is it. That's all, folks. Thank you so much. We will see in the next session about Unit 3. Thank you.